That window is between July 21st and July 30th of this year, although theoretically speaking the next eruption? It technically could start erupting before this video is published, or it could be another month before an eruption occurs. We simply do not know. I am basing this educated guess on the number of days uplift has been ongoing for, which before the prior two multi-week eruptions had been ongoing for 33 and 47 days, respectively. Also, the last two eruptions occurred after 13.89 million and 19.47 million cubic meters of magma respectively had pooled in the magma chamber 1,500 meters southwest of the Blue Lagoon at 5 kilometers depth. Since July 16 marks the 42nd day of ongoing uplift, which has reached 17 centimeters, and you combine this with the fact that an estimated 13.33 million cubic meters of magma is present in this body of magma, I hope that you can see where I am coming from with my prediction. Ever since mid-March, it appears that something in the Reykjanes volcano's plumbing system changed. No longer are eruptions limited to the volume of magma in the shallow 5-kilometer magma chamber, as it appears that molten rock during two of the prior eruptions bypassed the magma chamber after it drained and consistently supplied it for weeks at a time. Also, whereas the measured supply of magma had been decreasing to the shallow magma chamber ever since October 2023 with no change in this continuous decrease whatsoever, it has suddenly reversed this trend and began increasing since mid-March. So, what exactly might be causing this, which is seemingly triggering longer and more voluminous eruptions of the Reykjanes volcano? While volcanic eruptions on the Reykjanes eruptive periods peninsula can occur as isolated events, they generally occur as clusters during several decade to several hundred-year-long periods of heightened activity, only to be followed by hundreds to thousands of years of very minimal or no eruptions. Such periods have occurred between 1500 and 1050 BCE, 500 BCE and 100 CE, 800 to 1240 CE. And since 2020 we are in another such active period. This volcanism is caused by the mantle plume edge of the Iceland hotspot, which, according to a recently published scientific paper, sent large volumes of molten rock into the lower crusts sometime between 2002 and 2020. As a result, a massive 10-kilometer long, 5-kilometer wide, large magma chamber and 4-kilometer thick magma chamber was emplaced at 8.5 to 12.5 kilometers depth underneath the eastern Reykjanes and Fagradalsfjall volcanoes. Containing an estimated 26% melt, this figure means that a whopping 52 cubic kilometers of magma was emplaced without producing any earthquakes due to its location purely in the ductile crust. While some Icelandic locals might initially panic from hearing about the presence of such a massive magma chamber, in my opinion this figure is misleading. Most of this magma probably isn't eruptible, and sort of acts like pouring water into a nearly full container. What spills off once it is full and then a little more ends up erupting in its current state. In other words, deep recharges of magma are needed to send pulses of molten rock into the shallow crust, and I believe that a third such pulse occurred in mid-March. Since this deep magma chamber can remain in a similar state for hundreds of years, this is why we can expect many additional eruptions to occur across the next several centuries. If we are talking about the latest cluster of eruptions in the Reykjanes Peninsula, it likely will take another subsequent pulse of deep magma injection to occur before it shifts away to a different location, which could occur several months to a few years from now.